Hello everyone. In this question, it is asked that we are to find the roots of the equation 9x square minus 18 times mod x plus 5 equal to 0 belonging to the domain of the function fx equal to logarithm of x square minus x minus 2. Okay, so we are to find the domain of this function and see what values x can take, what interval x lies in, and we are to find which roots fit in that interval. Okay, so let us try to find the domain first. Okay, so fx is logarithm of x square minus x minus 2. Okay, now this logarithm function is defined only for positive real numbers. Okay, so this the term inside the bracket, this has to be positive and real. Okay, so this is defined if and only if x square minus x minus 2 is greater than 0. Okay, so this implies this cannot be equal to 0 because natural logarithm of 0 is negative infinity. Okay, so this is defined only for positive real numbers. So cannot be 0, strictly greater than 0. Okay, so if we factorize this, we get x minus 2 times x plus 1. This product is greater than 0. Okay, so this can further be simplified as x minus 2 times x minus minus 1. This product is greater than 0. Okay, so if we are given a product like x minus alpha times x minus beta and the product is positive, and we have say alpha is smaller than beta, okay, then this implies this that x is smaller than the smaller number, that is in this case it is alpha, right? So either x is smaller than alpha or x has to be larger than the larger number, that is x is larger than beta. Okay, this is because if x is smaller than alpha, then this becomes negative and x minus beta is also negative. Okay, so product of two negatives will give a positive product. Whereas if x is greater than beta, then x minus alpha is also positive and x minus beta also becomes positive. So either in this case we have two negative terms, product of two negative terms, which becomes greater than 0, or in this case we have product of two positive terms, which implies the product is greater than 0. Okay, so in this case the smaller number is minus 1, right? So let me write that term first. X minus of minus 1 times x minus 2 is greater than 0. So if we follow this trend, here alpha less than beta, here alpha is minus 1 and beta is 2. Okay, so either x has to be smaller than minus 1 or x has to be larger than plus 2. Okay, so this implies x is less than minus 1 or x is greater than plus 2. Okay, so this implies, if we write it in interval format, this implies x belongs to minus infinity to minus 1, open bracket, since it is strictly less than, strict inequality, union of 2 to infinity. Okay, so this is the domain of x. Okay, now let us try to solve the given quadratic equation. Okay, so now 9x square minus 18 mod x plus 5 equal to 0. Okay, now one thing is we have to note that mod x whole square, it is the same as x square. Okay, so since in the middle term we have mod x, we can rewrite this x square as 9 of mod x whole square. Okay, so now this becomes a quadratic in mod x. Okay, so this changes to 9 mod x square minus 18 mod x plus 5 equal to 0. Okay, so this equation, can it be factorized? The product is 45, right? And sum is minus 18. So 45 is like 15 minus 15 minus 3. Okay, so this can be factorized. So minus 15. So then we have 3 times mod x minus 5 times 3 times mod x 9 mod x square, and minus 5 times minus 1 is plus 5. Okay, so these are the two factors. So this implies either we have 3 times mod x minus 5 is equal to 0, which implies mod x is equal to 5 upon 3, and this implies if mod x is 5 upon 3, this implies x can take values plus or minus 5 upon 3. Okay, because mod x only gives the positive value, right? So if we take the modulus of, let's say we take the mod of minus 5 upon 3, this will only give 5 upon 3, right? And the positive value will always give the positive value. So if mod x is positive, by definition it is positive, x can take both positive and negative value. Okay, so in the other factor we get, if 3 mod x minus 1 is equal to 0, this implies mod x is 1 upon 3, 1/3, and this implies x can take the values plus or minus 1 upon 3. Is the factorizing all right? 9 mod x square minus 3 mod x minus 15 mod x 18 plus 5. Okay, so either x is plus by 5 plus 5 upon 3 or minus 5 upon 3, or x is plus 1 upon 3 or minus 1 upon 3. Now x is in this domain, right? X belongs to this domain. So in this domain, if we draw a number line, let's say this is minus 1 here and this is 2 here. Okay, then x belongs to this entire side. X is here and x belongs to the left of minus 1. Okay, x cannot be anywhere in between these two. Okay, now the values we get, 5 upon 3 is approximately 1.67. Okay, so 1.67 lies somewhere here. Okay, so this value cannot be taken. This does not belong to this domain of x, right? So this cannot be a root. Can we take minus 5 upon 3? So this will be minus 1.67. So this will lie somewhere here. Okay, minus 1.67. So this is in the domain. Okay, so this can be a root. Similarly, let's see what is 1 upon 3. 1 upon 3 is 0.3 recurring, right? 0.33 or 34. Okay, so this will be somewhere. Okay, I have not written here. This is 1.67. Okay, let's say 0 is somewhere here. So 0.33 is somewhere here, right? 0.33. Again, this is in the in the non-solution, non-domain region of x. So this cannot be a value. Okay, as it lies between minus 1 and 2, and this part is excluded in the domain. Okay, so this cannot be a root either. Now the last root that is left is minus 1 by 3. So this is negative 0.33 recurring. So this lies somewhere between minus 1 and 0. This will lie somewhere here. This is minus 0.33. Okay, so again, this also belongs to the non-domain region of x. So this also cannot be a solution. Okay, so the only solution we are left with is this. X is equal to minus 5 by 3, which satisfies this quadratic equation, and also is in the domain of x for the given function, that is logarithm of x square minus x minus 2. Okay, so therefore only root that satisfies domain of fx and given quadratic equation is x equal to minus 5 by 3, that is minus 1.67. Okay, so this is the only solution. So we only have one root that is satisfying this equation. Okay, so this is it. We have only one root here. Many extraneous roots are discarded because of this domain definition that we have discovered from this after solving this function, the domain of this function. Okay, so this is it. Okay, thank you.